Assalamualaikum warahmatullahi wabarakatuh. My name is Ammar Zaidi from section 01 engine design. Today I want to present about the design procedure of connecting rod under the engine component design chapter. So there is 4 steps of the design, which are dimension of cross section of the connecting rod, dimension of the crank pin at the big end and the piston pin at the small end, and the size of bolts for securing the big end cap, and lastly the thickness of the big end cap. So now for the number 1, dimension of cross section of the con rod. So as the picture shown, the design used as a strut, and we can see the cross section of the con rod and also the dimension of it in terms of height, thickness and base along both axis X and Y. Also the dimension use Rankine's formula for the buckling load. In order to have the con rod equally strong in buckling about both axes, the buckling load must be equal. If I section at X axis is greater than at Y axis, the buckling will occur at Y axis. And if the I section at Y axis is greater, then the buckling will occur at X axis. In order to have the con rod equally strong in buckling about both axes, the buckling load must be equal. If I section at X axis is greater than at Y axis, the buckling will occur at Y axis. And if I section at Y axis is greater, the buckling will occur at X axis. Next is the dimension of the crank pin at the big end and the piston pin at the small end. Since the dimensions of the crank pin at the big end and the piston pin at the small end are limited, therefore fairly high bearing pressures have to be allowed at the bearings of these two pins. The crank pin at the big end has removable precision bearing shells with a thin lining 1 mm or less of bearing metal such as tin, lead, babyit, copper and lead on the inner surface of the shell. And the bearing pressures on it depends on many factors such as the material, viscosity and space limitation between the shells. The values of the pressure might be 7 to 12.5 Newton per millimeter square. The piston pin bearing is usually a phosphor bronze brush about 3 mm thickness, and the allowable bearing pressure might be 10.5 to 15 Newton per millimeter square. Since the maximum load to be carried by the crank pin and piston pin bearings is the maximum force in the con rod, so that the dimensions for these two pins are determined for the maximum force in the con rod. This force is equal to the maximum force on the piston due to the gas pressure. So this is the formula. So next is the size of the bolts for securing the big end cap. The bolts and the big end cap are subjected to tensile force, which correspond to the inertial force of the reciprocating parts at the top dead center on the exhaust stroke. The bolts may be made of high carbon steel or nickel alloy steel. Since the bolts are under repeated stresses but not alternating stresses, therefore a factor safety may be taken on the bolts as figure show. Last but not least is the thickness of the big end cap. The thickness of the big end cap is determined by treating the cap as a beam, freely supported at the cap bolt centers and loaded by the inertial forces at the top dead center on the exhaust stroke. This load is assumed to act in between the uniformly distributed load and the centrally concentrated load. Therefore, the maximum bending moment acting on the cap will be taken as the figure shown. Thank you, that's all for me.